us start, please.
Should we start, Director Sir?
Good morning, sir.
Good morning to all of you.
Yes. So, very good morning to all of you. Our chief guest of today's program, Professor Sunil Kumar Singh, Director CSIR-AMPRI Goa. Guest of honor, Professor Ananda Subramaniam, Department of MSc, IIT Kanpur. Director CSIR-AMPRI, Professor Avnish Kumar Srivastava. Special invitee for today's program, Mr. P.S. Sardar, Deputy Commissioner, NVS Regional Office, Bhopal. Mr. Sumit Srivastava, Deputy Commissioner, KVS Regional Office, Bhopal. Coordinator, CSIR-AMPRI Jigyasa Program, Senior Scientist, Dr. Sadanand Mishra. Faculties who are present here from different KVS and NVS. My colleagues, on behalf of CSIR-AMPRI, I warmly welcome you all on 5th National Science Teachers Workshop 2022, which is based on Self-Reliant India using cutting-edge science and technology, to be held on 4th and 5th February 2022, organized by CSIR-AMPRI. CSIR-AMPRI strongly believes in culminating scientific temper among various sections of academics, and in continuation of our tradition, we are organizing this two-day workshop for the Science Teacher Workshop. So to start with the program, I invite the Director, CSIR-AMPRI, Professor Avnish Kumar Srivastava, for welcome address. Sir, please. Sir.
Once again, good morning to all of you. Namaskar.
Good morning, sir.
Morning.
Good morning, sir.
Morning, sir.
Morning, sir.
Good morning.
Good morning to all of you.
At the outset, I would like to welcome all of you for this very important program, on National Science Teachers Workshop on Self-Reliant India using cutting-edge science technology. We are fortunate to have with us today Professor Sunil Kumar Singh, the Director, CSIR National Institute of Oceanography, Goa, Professor Ananda Subramaniam from the Indian Institute of Technology, Kanpur, Mr. P.S. Sardar, Deputy Commissioner, NVS Bhopal Region, Mr. Sumit Srivastava, Deputy Commissioner, KVS Bhopal Region, my own CSIR family members, Dr. Subramaniam Mishra, Dr. Archana Singh, and all scientific, non-scientific CSIR-AMPRI staff, and all participants. I heard it's about around 600 teachers, faculties, their principals, and I'm sure students and sometimes parents too. I have joined this online program. So I welcome all of you for this very important occasion. This program is being organized under CSIR Jigyasa, and CSIR Jigyasa is the program which started between Ministry of Human Resource Development and Ministry of Science and Technology. Sorry, CSIR in July 2017 by signing an MOU, and under that MOU, it was like that the scientists and other technical staff of all CSIR labs, that time 38 CSIR labs, will interact with the students, faculties, principals, deputy commissioners, and all Kendriya Vidyalayas staff. And in 1 year, target was to reach 1 lakh students and about 1,000 faculties. It was the target in the year 2017 for all CSIR labs across the country. And you know, CSIR labs, they are working almost in all the fields of science and technology, starting with biosciences, environment sciences, oceanography, engineering sciences, chemical sciences, physical sciences, and so on. So it covers all the fields. And at present, CSIR-AMPRI AMPRI stands for Advanced Materials and Process Research Institute. It is one of the constituent lab of CSIR located in Bhopal. And this is the only CSIR lab in Madhya Pradesh and Chhattisgarh, two states. And this is the only lab of CSIR which is completely dedicated to work on engineering materials, advanced materials and advanced processes. So we, being the part of this CSIR Jigyasa program, we also started interacting with the Kendriya Vidyalaya students. And of late, when MOU was signed between Navodaya schools and CSIR in the year 2020, we started interacting with Navodaya schools also, Madhya Pradesh, Chhattisgarh, and Odisha. So that is how this program started. And by now, if we count the number of the students and faculties we have reached in last 4 years of Navodaya schools and Kendriya Vidyalayas, we find it's more than 1 lakh students and faculties we have already got connected through our science and technologies programs which we are having at AMPRI. Mainly, our institute is working on lightweight materials, nanostructured materials, cementary and concrete materials, and radiation shielding materials, variety of composites, waste to value-added materials. I request all others to mute their mic, please. Sensors and actuators, and advanced processing routes like electromagnetic forming and LED printing. I request all others to please mute. In the recent past, we have developed various advanced technologies solving the issues, societal issues like parali burning in the states of Delhi, Punjab, Haryana, where the paddy is burnt in the month of starts around the Diwali period, October to December, January, and you hear on TV channels that Delhi has become the gas chamber, so on. So we have developed technology to convert this parali to the composite. Similarly, the other technologies like bamboo-based composite, and these composites are the replacement of wood, sometimes the replacement of teak wood. Then we have developed radiation shielding tiles from the waste material of red mud, which comes out from alumina industries. Then cement-free concrete materials we have developed using the fly ash. Fly ash is the waste materials from the thermal power plants. I think still some mics are mute. Please, I request participants to mute their mic. Even we interact with other CSIR labs. And for example, we have interacted with Central Building Research Institute, Roorkee, and we have come out with joint technology of makeshift structures for hospitals and clinics. And during the first wave of this COVID, we erected one clinic in JP Government Hospital in Bhopal. And during second wave, we erected another clinic at Devas. It's about 200 kilometers from the Bhopal. And now AMPRI has taken challenge in erecting one hospital, a makeshift hospital with the support of Bill and Melinda Gates Foundation at Nandurbar district. It's in Maharashtra. It's again a drive area. So whatever we are doing, we are trying to have technologies finally, and our research starts with the fundamental research. Very recently, we have also published papers in Nature, Communication, Nanoenergy, and so on. So we start with the fundamental research, converting it into applied research, and then moving towards the technology development in the industry interfacing and societal. Coming to today's topic, the self-reliant India. As we all know that even our great Mahatma Gandhi ji also said that self-reliance is the key to success. And during this pandemic situation, our Honorable Prime Minister of India and the President CSIR, Shri Narendra Modi ji said that Atmanirbhar Bharat. And this was the term coined on exactly, I think, on 12th May 2020. And he was talking about some business strategies regarding the PPE kits. And 5 pillars which were identified under Atmanirbhar Bharat are economy, an economy that brings quantum jump rather than incremental change, and demography, that we have very vibrant demography, which is our strength. Infrastructure of any system is starting from the institute to city to state to country. It's very important to have anything further. Then system and demand. So these are the 5 pillars which comes under the consideration of Atmanirbhar Bharat, where we need to strengthen, we need to utilize, and then finally we have to grow. And coming out from this, the tag of developing countries, we have to come out from this tag and to be called as developed countries. Even at international scale level, if you hear the important quotes and speeches, you find the issues are basically at present economic instability, health, climate change, and so on. So whatever we are doing in the field of science and technology through the intervention of science and technology, probably we can solve most of these things. And the growth engine, when we talk about growth engine of any country, the main component we all know is science and technology. And we are working in that direction. In this context, the industry 1.0 to 4.0 is playing important role again. Industry 1.0, which started sometimes in late 18th century with the power steam engine mechanical systems. And now we are talking about industry 4.0, where we deal with artificial intelligence, big data science, cloud computing, 3D additive manufacturing, and so on. And then industry 5.0 is also on, where persons have to work alongside with robots and modern systems. So all these things are somewhere interlinked, and science and technology is going to play very important role. It has played very important role, and in present and future also, it's one of the component, a very important component of growth engine of the. So in this context, when we arrange this kind of workshop in a National Science Teachers Workshop, it's very important because our faculties, and I believe somewhere we all are faculties at different positions. And here we are talking about the faculties of Navodaya schools, Kendriya Vidyalaya, and I'm also heard about that some faculties from the state government schools and private schools are also connected with this. So it's very important for the faculties to get upgraded in terms of the science and technology, what is going on in the national and international forum. And in that context, I believe that this workshop is going to be very important. Although we may not be able to cover all the topics, but definitely some of the topics are going to be covered. We have got very eminent speakers, starting with Professor Sunil Kumar Singh, Professor Ananda Subramaniam, and so on. They are very eminent speakers, so you are going to enjoy this workshop. Even validative function, I can see a person like Dr. Partha Ghoshal from Defense Meteorological Research Lab, and so on are there. So varied speakers, varied topics, and the faculties, teachers from different schools, different areas, different states are there. So I'm sure that it is going to be very useful for all of us, even for organizers also it is going to be very useful. And so once again, welcome to all of you and all the best for this workshop, and have a good day today and tomorrow both. Please try to attend all the lectures wherever possible and enjoy it. And once you are through with these lectures, please try to share your thoughts and views and whatever you have learned with your colleagues, friends, and your students. With this, namaskar. Thank you.
Thank you, sir. Thank you so much for highlighting the CSIR-AMPRI's work and its achievement. Also about the Self-Reliant India and its pillars, briefing Jigyasa program and CSIR-AMPRI's contribution in Jigyasa program. Thank you so much. So before I go ahead, I request all the participants to kindly mute their microphone throughout this meeting, because this meeting is being recorded and will be put in a public platform. So it is necessary to maintain the quality of this recording. Thank you for all of your help. Now, to go ahead, I invite Dr. Sadanand Mishra, Senior Scientist and Coordinator, CSI Jigyasa Program at AMPRI, to brief on Jigyasa Program on today's workshop. Thank you. Dr. Mishra.
Thank you, madam. A very good morning to one and all. Respected today chief guest, Professor Sunil Kumar Singh, Director NIO Goba. Guest of honor, Dr. Anand Kumar Subramaniam, Professor MSc Department, IIT Kanpur. Mr. P.S. Sardar, Deputy Commissioner, Navodaya Vidyalaya Samit Bhopal Region. Mr. Shobhit Srivastava, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Bhopal Region. Professor Avnish Kumar Srivastava, Director CSIR-AMPRI Bhopal. Participants of the workshop, our colleagues and other dignitaries. A very welcome to all in the 5th National Science Teacher Workshop 2022 organized by CSIR-AMPRI Bhopal. The theme of this workshop is Self-Reliant India, using cutting-edge science and technology. This is the current demand. Before going to the details of this workshop, I wish to brief you about the journey of National Science Teacher Workshop, which have been organized by CSIR-AMPRI. First workshop was organized in November 2017 with 30 teachers. Second workshop organized in November 2018 with 50 teachers, and third workshop organized in November 2019 with 150 teachers. Fourth workshop is organized March 2021 with 250 teachers, and at present we are here in the 5th workshop with 550 teachers which registered. I think it's the number increased and become the 600. This is the success journey of our workshop. The 5th National Science Teacher Workshop is being organized by 2 days. In the first day, the program is starting with inaugural ceremony. Today, chief guest is Professor Sunil Kumar Singh, Director, CSIR National Institute of Oceanography, Goa. Dr. Singh has been awarded with prestigious Bhatnagar Award. Dear participant, this is the Bhatnagar Award, known as the Indian Scenario, as a Nobel Puruskar. This is proud feel. Our speaker is with Bangas. He will deliver talk on the topic Blue Economy, Scientific Science and Technological Intervention. Today's guest of honors, Dr. Ananda Subramaniam, is a very eminent professor in MSc Department, IIT Kanpur. Dr. Subramaniam deliver talk on the topic Learning with Model, Experiment and Video. This is the current demand in the COVID pandemic. This is the necessity to all of us to know the new teaching and learning process. We have to especially invite Mr. P.S. Sardar, Deputy Commissioner Navodaya Vidyalaya Navodaya Vidyalaya Samit Bhopal region, and Mr. Shobhit Srivastava, Deputy Commissioner KVS, he also addressed the August gathering. After the inaugural ceremony, in session first, Professor Anuj Hunde will deliver a lecture on innovative use of information technology in teaching and learning process. Nowadays, we are going through IT and artificial intelligence and using these technologies for the learning and delivering talks. In session second, Dr. Manish Mudgal will deliver a lecture on advanced fly ash-based geopolymer eco-friendly concrete for infrastructural application. Nowadays, everybody knows that eco-friendly terms, and this is also a current demand. So I include this topic in this workshop. In session third, Dr. Bandana will deliver a lecture on silicon PV technology, progress and advanced concept. We are using day-to-day silicon technology, micro chips we are using and familiar and used to. So this topic is also important. As on 5th February 2020, in second day, in session 5th, Professor P.S. Tiwari will deliver a lecture on emerging challenges and role of science and technology. In session 6, Dr. Kirti Soni will deliver a lecture on calibration and assessment of air quality equipment. In session 8, Dr. Sarika, in session 7, Dr. Archana Singh will deliver a lecture on carbon-free future energy source hydrogen, which is also a current demand. In session 8, Dr. Sarika Burma will deliver a lecture on recent advances in carbon-based nanomaterial for health care application. In session 9, Engineer H.N. Bhargav will deliver a lecture on application of smart materials as an actuator. In the last session, valedictory. In the valedictory ceremony, Dr. Partha Ghoshal, Scientist G and Help Electron Microscopy, DMRL, DRDO Guest of Honor, Professor Vivekanand Singh, Civil Engineering Department, National Institute of Technology, Patna. A special invitee, Mr. Tajuddin Sheikh, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Jabalpur region, and Mr. Vinod Kumar, Deputy Commissioner, Raipur region, will address the August gathering. Dear participants, Jigyasa, that is inquisitiveness, play a very important role in our life. Without Jigyasa, हम कुछ भी नहीं कर सकते अपने लाइफ में, है ना? तो what is the life? Really, life is like the moon. Good and bad time comes soon. Life is like a football, up and down, always on. Life is like a chess, everyone wants success. Life is like a target, when we concentrate, we get. Life is like a lesson, learn it with a passion. Life is like a stage, perform every time, forget your age. Life is like a test, give your best. Life is not a rest. Don't make it waste. With these words, I finish. Thank you once again. Jai Hind, Jai Bharat.
बताओ तो
Dear participant, please mute your mic.
Thank you, Dr. Sadanand Mishra, for briefing audiences about the Jigyasa program and on the success journey of various science teachers workshop being organized by CSIR-AMPRI. Thank you so much. For today's program, we were to be joined by Mr. P.S. Sardar, Deputy Commissioner, NVS Bhopal region. However, because of his health issues, he will not be able to join. So we will go ahead and now we have another special invitee from KVS Regional Office Bhopal, Mr. Shobhit Srivastava with us. Mr. Shobhit Srivastava is currently posted as a Deputy Commissioner, Kendriya Vidyalaya Sangathan in Bhopal region, where he is supervising educationally, academically, and financially 68 schools, accommodating around 70,000 students and 2,000 teachers. He has Masters in Physics and also he has Masters in Education. He has served in KVS and capacity of PGT as an educational officer and then Deputy Commissioner in the various regional offices of India. So it's really, we are very happy to have you with us, sir. Mr. Sumit Srivastava ji, I invite you to please address the gathering. Mr. Sumit Srivastava, please. Mr. Sumit Srivastava, are you there? Dr. Mishra, can you please update about his presence, sir? Dr. Sadanand Mishra?
In the participant list, I searched by name, he is not there. By name, he is not there in the participant list.
Okay, I think Dr. Sadanand Mishra is contacting me. So,
Yes, ma'am. He is contacting.
Okay.
yeah.
Madam,
Yeah.
Mr. Srivastava will join soon. He is in another meeting and within a minute. Now,
Yeah, okay. Dr. Sadanand Mishra, if he is taking time, then we can go ahead and later on he can join whenever he is there.
I think we can wait a minute. If
Okay.
it comes, it's okay.
Okay.
So this COVID has really taught us how to use these different platforms to connect. And thanks to information technology, that at least we can see each other, we can talk to each other, and we can share our views, and we can discuss among us. Otherwise,
Amniji, you were telling about this nature communications from AMPRI. That's very impressive.
yeah, we have published a paper in Nature Communication on graphene. How graphene can be used to reduce this wear resistance. And so it could be very important for this automobile industries. Think and all the small components where you can reduce the energy which is wasted in friction. So we have published in Nature Communication.
Because I'm seeing that some of the papers which originally went to Nature nowadays are pushed to Nature Communication. So there is a lot of competition there also.
Yeah, definitely.
And it has also got a, I would say, a bloated impact factor, but still a very high impact factor. So,
Yeah, that's true.
so getting through any of these journals has become progressively difficult in the last 15 years, I can see.
Yeah, that's true. We have also published a couple of papers in nano energy also, nano piezoelectric materials, oxide base, oxide graphene combination. So, and we are probably among very few, first I should say, were published on graphene SS based composites using this additive manufacturing.
That's amazing.
Yeah, in material science, engineering, and all, we have published just 2 years back before. And we are trying to establish a center. We are trying to establish a center on this graphene-based materials and devices in AMPRI. Last year, we have already established a center, independent building, on Center for Advanced Radiation Shielding and Geopolymeric Materials. You may recall the other side of the road campus. This building has come up. And other than the Cabinet Minister, Dr. Harshvardhanji, he inaugurated that center.
Wow.
Yeah, so, and now we are getting demands from strategic sector, including Indian Navy and all too. They want to use this radiation shielding tiles, which are lead free for their health sector. So we have transferred the technology to Mrs. Prince Johnson also. So you know that when technology goes from lab to industry, that gap one needs to be filled, because at lab you work at lab scale, industry works at industry scale. So here if you talk about gram, you think you are talking in bulk. But if they talk in terms of tons, still they think that they are talking in some small amount. So that is the difference. So that is the gap we are trying to fill up. But we hope very soon product launch will be there. So this tiles industry, in fact, first time we'll have a new kind of tiles in the country at least. I'm not sure about world scenario, but to the best of my knowledge, so far it's not there. The tiles industry will have radiation shielding tiles also. So far it is not there. So Prince Johnson has taken that technology.
I think Sumit Srivastava has joined.
Yes.
Yeah, so we can welcome Mr. Sumit Srivastava.
Very good morning, sir. So we have Mr. Sumit Srivastava, Deputy Commissioner, KVS RO Regional Office, Bhopal. So, Mr. Sumit Srivastava, it's really honor to have you with us today, sir. I invite you to address this gathering, sir. Please, sir. Hello, Mr. Sumit, can you hear us?
Swami sir, I think your microphone is mute. Please unmute yourself.
I think now I'm audible.
Yes, we can hear you.
Sadanand Mishra ji, teachers and dear students from Kendriya Vidyalayas, from Navodaya Vidyalayas, and also from other schools. First of all, I would like to express my happiness because I am a part of this program. CSIR-AMPRI has been conducting several programs for the benefit of the student community. And the teachers of Kendriya Vidyalayas particularly have also been benefited on various occasions because of these initiatives, because of programs under the banner of Jigyasa. And friends, I believe that the programs conducted under the banner of Jigyasa, they are quite informative, and they in fact expose students and teachers to the emerging frontiers of science and technology, and they acquaint students and teachers with new developments which are happening in the field of science and technology. CSIR-AMPRI is in fact a world-class institution, and which is actually creating new materials and the processes related to the new materials. And these new materials are required in future in various fields, the construction materials and also various other applications. We have been informed by the scientists of CSIR-AMPRI about the various products which they are making or which they are in the process of making. So in fact, I congratulate for all these initiatives taken by CSIR-AMPRI. And I hope that with programs such as these students would be lured into working in science, in various disciplines of science, and they will have a very good career in science, and attracted to various research projects which are currently underway in many CSIR laboratories across the country. And they will have a fantastic career. They will have a very satisfying career, because when they produce something new, when they expand the horizons of knowledge, when they create something new materials or new process or new methods, then they will have immense satisfaction. I personally believe that human satisfaction is at the highest level when it expresses itself in the form of creation. So anything which you create anew, that will give you immense satisfaction. So once again, I congratulate CSIR-AMPRI for involving me and for involving students of Kendriya Vidyalayas and also students from other school systems for these initiatives. And in fact, through this, I take this opportunity in reiterating that that Kendriya Vidyalayas under Bhopal region and students and teachers, they will be forever ready for new initiatives that CSIR-AMPRI might be planning in future. Thank you, and God bless all of you. Back to you.
Thank you, Mr. Sobit Srivastava. Actually, it's the constant support from the KVS, NVS, and other schools and their deputy commissioners which make these events successful as much as possible. So we really thank you for your constant support and help even at the short notices. Thank you being here, sir. Thank you so much.
Thank you very much.
So now to go ahead, we are really honored to have Professor Ananda Subramaniam from Department of MSc IIT Kanpur as a guest of honor for today's program. Before I invite Professor Subramaniam, I will take the privilege to introduce him to the audiences who are present here. Professor Ananda Subramaniam did his BTech from IIT Madras, followed by Masters in Engineering and PhD from reputed institute IISc Bangalore. He served as a scientist in CSIR, and then he moved to Germany at the Max Planck Institute for Metal Research at the Stuttgart, where he worked in the capacity of Max Planck Fellow as well as an Alexander von Humboldt Fellow. After these experiences, he joined at IIT Delhi in Department of Applied Mechanics and eventually moved to IIT Kanpur in the Department of Material Science and Engineering, where he is currently serving in the capacity of professor. He is recipient of many awards. Some of them are International Award, the Sri Ram Arora International Award for Material Science and Engineering Education from TMS USA, Young Research Award from IUMRS, and so on. His current area of research interest are physical material science, quasi-crystals, nanomaterials, symmetry, crystallography, hydrogen storage in materials, and so on. Professor Ananda Subramaniam has published a number of publications on metals, semiconductors, insulators, ceramics, and so on. The video courses and ebook developed by him, which is mainly based on material science and engineering, a learner's guide, is referred globally by students and teachers. Professor Anand Subramaniam has executed many projects, and currently he is recently established the IIT Kanpur wing of Multi-Institutional Center on Hydrogen Energy System under the aegis of DST Energy Storage Platform on hydrogen. He is the pioneer of the green energy theme in the Center for Environmental Science and Engineering Department of IIT Kanpur. Also, he is one of the founding members of the Department of Sustainable Energy Engineering at the IIT-K Rice Center on Sustainable Energy Technologies at IIT Kanpur, which has hydrogen energy as an important focus area. It's really an honor for us to be with you, for that Professor Subramaniam is with us today, sir. He will be delivering talk on learning with model, experiments, and video. So now I invite Professor Ananda Subramaniam for his talk. Sir, please, sir.
Thank you very much, Dr. Archana. Thanks, Dr. Sadanand and Dr. Manish for kindly inviting me today. What I did was I just, whatever ready-made I had, I sent it across. Maybe I should have written only one line. So Anand teaches in IIT Kanpur. So that should have been my introduction, which should have saved a lot of time today. Anyhow, so I have a deep association with both Kendriya Vidyalaya Sangathan and AMPRI Bhopal. So this is a nice place to be. I have from 1st standard to 12th standard studied in Kendriya Vidyalaya, KV Tom Fatak Jaipur, KV Malleshwaram Bangalore, KV Janakpuri Delhi. I have studied across the country in Kendriya Vidyalaya from 1 to 12. I have been immensely benefited from the teachers of Kendriya Vidyalaya, and so the very good association. Just to get you that AMPRI, of course, I have been a scientist in AMPRI, and Dr. Das, who was a director there, was twice my colleague. Once he was also a member of my own department, material science and engineering here, and so also at AMPRI have been his colleague. Just last week also I happened to be talking to Dr. Amrit Phale, who is now at Louisiana, a faculty at Louisiana Tech, I think it's in Baton Rouge. So who also has been acting director of AMPRI. So very close also. Next week I'm coming to Bhopal, so I'll be meeting Amish in person, I hope. So today I will try to take minimal amount of time. So in the first figure, you see something called a dodecahedron on the right hand side. I have a model of that here, and I will tell you why it is important to learn. But before, I need to share my screen. Just sorry, I need to share my screen. I have not done it.
Yes, sir.
I will share the screen. Okay, so that, sorry that this is going to be a little small, because what I'm doing is that I'm not sharing the entire application. I'm just sharing the screen. I hope this will reasonably work well. Are you able to see the screen?
Yes, sir, but
Yes,
it's
sir.
not. Yeah. Yes, Narendra, please.
Is it too small? Is it visible? Is it clear?
Yes, sir, it is clear.
Yes, sir, it's clear.
Okay. So you see a dodecahedron on the right hand side. I will show a little bit more about that. But before I start, there are a few problems which all of us face. Teachers must be facing a lot of additional workload. If you are in a government and a KV, I can tell you that the workload is immense, right? And then what you think is that it's really immense. I'm telling you, a lot of additional work keeps coming on and on and on. And we sometimes think that, okay, we'll become a principal, the load will come down. No, when you become principal, the load is even more. Even Director AMPRI knows that every single problem comes to him, right? He is extremely low. In spite of his ill health, he is present today here, right? So this workload is a serious problem, and managing it is one of the key issues that all of us have to face, because in government, the load keeps increasing. So I'm thankful to the teachers that in spite of all that, they're taking time out to be present here today. So please, this is something which is a serious issue. I don't know how to address it, but I just want to point it out. Okay. And managing a workload is a very important thing. Second thing is, for students' perspective, the syllabus is vast. Now we may think that that it's okay. More information means more learning. It is not so. It is not a linear curve. You keep on increasing the syllabus. At some point of time, the learning decreases, and therefore students also facing a lot of problem in terms of the high amount of syllabus. I wish I could even remember 20% of what I learned in school. I'll be able to do fantastic research today if I remember only 20% of what I learned in school. Okay. So, but it is therefore, if the syllabus need not be vast, but unfortunately in India we make vast syllabus. I don't know. I'm perhaps equally guilty when I start new courses. Like for just now, sustainable energy engineering, we started entire MTech, MS programs. I was making syllabus for many of those things, curriculum. I tend to make it more intense, and that is a big problem for students. Now that again, I don't have a simple solution, but I just want to point out that sometime if we can reduce the amount of homework given to students or allow them to explore using alternate methods, that is more learning than just merely covering the syllabus. As Rajesh Prasad used to quote a famous professor, Rajesh Prasad is a common lab mate between myself and Professor Avnish. So he used to say that the job of a teacher is to uncover the syllabus, not cover it. So the third thing is learning. So for whatever reason, those, you are in Germany, you are doing your postdoc, everything you've done. And then you think that you know the subject. When I started teaching in IIT Delhi in applied mechanics, niche patal khul gaya. Patal, literally patal opened below my feet. It said that I don't understand the subject at all. मेरे को कोई भी समझ नहीं है सब्जेक्ट की. I'm not talking about little, not knowing a little bit. पेपर छाप लिए, बड़े बड़े अवार्ड जो भी नाम बताए थे वो सब प्राप्त कर लिए, लेकिन ज्ञान का काफी अभाव नजर आया. So then what do you do? भाई अभी आप डॉक्टरेट लगा लिए दीवार पे, ये सोचा कि हम सीख गए सब कुछ, लेकिन मैंने तो कुछ सीखा नहीं, पर समझ में आ गया. Now what do I do? Now I had to start learning and literally start learning from scratch. Believe me. BCC क्या होता है? आयन क्या BCC है? वहां से बिल्कुल जो एलिमेंट्री बोलते हैं ना, वहां से सीखना शुरू करना पड़ा. It has been a good journey, thanks to good friends across, and just now I'm showing you two sources which are referred pretty well in the country and globally, which is the ebook and NPTEL. Today morning a mail has come to me pointing out a mistake in my ebook. Like आपने गलत derivation किया किताब में, ये ebook में. So this is how we find that in spite of thinking that we know, we keep making mistakes and we start learning. Today morning, I'm not even talking about yesterday. आज एक मेल आया स्टूडेंट से कि भाई मैं अपनी गलती कर दी है डेरिवेशन. मैंने कहा जाके देखना पड़ेगा, सुधार करना पड़ेगा. तो लर्निंग इज, डोंट थिंक दैट 40 के हो गए, 50 के हो गए, भाई टाइम नहीं मिल रहा सीखने के लिए. बिकॉज वंस आई लर्न, देन आई बिकम अ बेटर टीचर. And this is something I learned from, for instance, I was mentioning Dr. Rajesh Prasad. He's a Gyan Guru of material science. Dr. Avnish himself, very knowledgeable. वो एक सेशन में उतनी मेट्रोग्राफी कर जाते थे जितने कि हम महीनों में ना कर पाए. मतलब जाते थे डार्क रूम में और प्रिंटिंग करके आते थे, मतलब मेट्रोग्राफी करके लगता था यार ये क्या कर दिया उन्होंने. आई शोड यू पिक्चर इन द प्रीवियस स्लाइड. इस तरह के मेट्रोग्राफ तो रोज 2-4 प्रोड्यूस कर ही देते थे. दिस इज अ नाइस सनफ्लावर फ्रॉम द जिंक मैग्नीशियम अलॉय. सो प्लीज devote time to learning, so that don't think that teaching is meant by teaching. It's also a lot of learning, and when you learn, then you teach better, I presume. And I had to start late in my life. I presume that I also learned it's never too late. Okay. Now, the topic is that कि हम लोग क्या करते हैं, काफी theoretical ज्ञान देते रहते हैं. I'll try to minimize my talk. तो अगर theoretical ज्ञान देंगे तो प्रॉब्लम क्या आती है कि वो चिपकता नहीं है दिमाग के अंदर. It is very difficult to digest it, understand it, and hold it in your brain. So it is better that you show models, right? You do experiments. And now, sometimes you may think, sir, where is the facility to do experiments? Most of the experiments are not very, very difficult. Okay. I'll just show you one small experiment here. I'll just switch my camera a little bit because I use this orientation for teaching my classes here on the ebook, when I'm teaching to students. Okay. I'll just show you material here. This is my table here. So let me go down to the blank part of this class. So you see, this is some kind of an egg or something, but this is just the packaging. Inside this, there is a material. Okay, this is a nice clay kind of material जो बच्चे खेलते हैं ना, clay. Okay, so let me bring it to the camera. So you see, this is a nice clay kind of material. Okay. So now what happens? This material, you think that अरे अपना normal Chinese clay है, लेकिन what you do is, suppose I make a ball out of it, and then I bounce it. It bounces. Bounce कर रहा दिख रहा आपको? So you can see that unless you take this material in your hand and try to do this experiment, you will not believe such a material exists, right? जो कि clay की तरह mold हो जाता है लेकिन bounce भी होता है, right? Now I showed you this dodecahedron. I have a small model of a dodecahedron here, right? एक और solid है, मैं just बता रहा हूँ कि जब मैं बता रहा था कि कितना कभी कभार हम सोचते हैं क्या रिसोर्स लगेगा, इसको बनाने में क्या रिसोर्स लगता है, पेपर है, बस चिपकाया हुआ पेपर है, या फिर ये डंडों से बनाई जा सकती है, टेट्राहीड्रन है. अब जब तक मैं टेट्राहीड्रन को हाथ में नहीं पकड़ता, मेरे को टेट्राहीड्रन समझना बहुत मुश्किल है. I need to have a model in my hand. Why? Because टेट्राहीड्रन कभी भी आप किताब में देखेंगे तो ऐसा ड्रॉन होता है, right? 3-fold upward, मतलब जहां की त्रिकोण ऊपर से नजर आता है, लेकिन टेट्राहीड्रन का 2-fold भी आपको होना चाहिए. देखिए, इट्स अ टू फोल्ड एक्सिस, दैट मीन्स यहां से अगर मैं 180 डिग्री घुमाऊंगा तो वैसे का वैसा दिखाई देगा ये। ओके, तो अगर एक एज कितने से कनेक्टेड है, फॉर इंस्टेंस ये वर्टेक्स है, ये 3 से कनेक्टेड है, जब हाथ में मॉडल होता है तभी समझा जा सकता है, ठीक है। और ये बात अभी जानते हैं, लेकिन और अक्सर हम सोचते हैं कि बहुत मुश्किल है ये हमारे लिए मॉडल बनाना, है ना, लेकिन नहीं है। वी कैन मेक सिंपल मॉडल्स विच आर इनएक्सपेंसिव, लाइक दिस वन, दिस इज मेड बाय यूजिंग समथिंग कॉल्ड जोड़ो ज्ञान। वो ऐसे कनेक्शंस बेचते हैं हमको, लेकिन खुद भी बना सकते हैं, कोई बड़ी बात नहीं है, तो बस डंडों से बना है। इनफैक्ट माय स्टूडेंट्स हैव मेड ब्यूटीफुल, वो झाड़ू के पत्ते होते हैं ना, वो झाड़ू की तिलियां होती है, उनसे बहुत बढ़िया बढ़िया मॉडल बनाया हमारे स्टूडेंट्स ने। नाउ दिस सॉलिड आई वाज मेंशनिंग इज अ डोडेका हीटर। अभी सॉलिड इतना स्पेशल है कि इसको बोलते हैं कि इट्स अ क्राउनिंग ग्लोरी ऑफ ग्रीक सिविलाइजेशन। मतलब ग्रीक्स ने जब उनकी इतनी डिस्कवरीज है, इतनी बड़ी बड़ी चीजें, उसकी सबसे बड़ी उनकी पहचान ये है कि उन्होंने ये सॉलिड बनाया। अब वो बोलेंगे कि ये देखिए तो बहुत सिंपल सॉलिड है, इट्स कॉल्ड वन ऑफ द प्लेटोनिक सॉलिड्स, बट इसकी डायरेक्ट इसकी डिस्कवरी मटेरियल्स में 1984 में हुई। मतलब ये तो ज्योमेट्रिक सॉलिड तो पता था 2000 साल से ऊपर का, प्लेटो के टाइम से, लेकिन क्या इसकी कोई मटेरियल से कनेक्शन हो सकती है? ये 1980s में डिस्कवर हुआ, कितना लेट सोचिए। और इसकी नोबेल प्राइज मिली 2012 या 10 में, इस रेंज में। तो मतलब ये कि इस सॉलिड का कनेक्शन मटेरियल्स के साथ हो सकता है, इस सिमेट्री का। और इस सॉलिड को समझ अगर कोई समझ पाए तो ये देखिए बड़ा उसका वैसी का वायरफ्रेम मॉडल है। तो इसमें देखेंगे कि आप कि इसके हाथ में एक मॉडल रहना बहुत जरूरी है ना। क्योंकि आप देखेंगे कि एक यहाँ पे एक 3 फोल्ड कनेक्शन है, इसका 3 जगह से कनेक्टेड इसका एज, हर एक फेस एक पेंटागन है, राइट। और अगर आप इसको 2 फोल्ड अप भी रख सकते हैं, देखिए जैसे दो तो ये एक सॉलिड है जो कि दिखता काफी मुश्किल है, और इसको समझना होगा तो हमें क्या करना पड़ेगा कि वी शुड ट्राई टू हैव अ मॉडल इन हैंड। नाउ आपको 2-3 एग्जांपल मैं नेचर से देता हूं। जैसे कि अगर आप बात करते हैं, हम लोग जैसे हमारे मटेरियल साइंस में क्रिस्टल की बात करते हैं, या आप केमिस्ट्री में क्रिस्टल की बात करते हैं, तो देयर इज नथिंग लाइक एक्चुअली सीइंग क्रिस्टल। ये हमारे कुछ रॉक ग्रोथ है, इसमें आप देखेंगे ये क्रिस्टल बने हुए, ठीक है। और इसी प्रकार से ये एक और क्रिस्टल है, ये देखेंगे आप, ये एमेथिस्ट है, अंदर हॉलो है और इसके अंदर से क्रिस्टल ग्रो हो रहा है, ठीक है। और एक बहुत अच्छे पेपर है हमारे चाइनीज के प्रोफेसर ने छापा है कि कैसे क्रिस्टल उन्होंने बाहर से अंदर की तरफ एक मटेरियल में क्रिस्टल ग्रो किया। ये तो नेचर ग्रो कर ही रहा है ऐसा, इसी प्रकार का क्रिस्टल उन्होंने आर्टिफिशियल लैब में बनाया, ठीक है। और हमने भी एक हॉलो सिंगल क्रिस्टल लैब में बनाया। दैट मींस क्रिस्टल कभी हॉलो होता है क्या? नहीं होता है, लेकिन सिंगल क्रिस्टल वो भी हॉलो, ठीक है। तो जब आप स्टूडेंट को दिखाएंगे कि भाई ऐसे ऐसे क्रिस्टल्स होते हैं, और इंडिया में तो पता नहीं, वेस्टर्न कंट्रीज में इस तरह के क्रिस्टल्स के शोज होते हैं। शोज मतलब उसको बोलते हैं हमारे की एग्जीबिशंस। जैसे हमारे कंट्री में डिफरेंट टाइप के एग्जीबिशंस होते हैं, वहाँ बहुत बड़े बड़े एग्जीबिशंस होते हैं जिसमें कि इन मिनरल्स को दिखाया जाता है। और ये छोटा सा जो अमेथिस्ट दिखाया मैंने, ये अक्सर इसकी 3 फुट 2 मीटर की हाइट की ऐसी अमेथिस्ट फॉर्मेशंस होती है, और इतनी सुंदर दिखती है। तो जब तक कि हम लोग अगर मॉडल ना दिखाएं, एक्चुअल एग्जांपल्स ना दिखाएं, तो वो ग्रहण करना बहुत मुश्किल होता है। और हमें लगता है कि, और ये मॉडल मैंने कहाँ से ली होगी, एक बार मैं कोलाबा कॉसो में जा रहा था, क्या कहते हैं, बॉम्बे में, तो खरीद लिया सही, रोड साइड से रखा हुआ था। तो दिस इज हाउ हम लोग एक मॉडल बनाएंगे तो समझ में आएगा। नाउ मैं आपको कुछ और पिक्चर्स दिखाता हूँ यहाँ पे। आपको मेरे स्लाइड्स देख पा रहे हैं?
यस सर।
ओके, तो ये जो हम जानते हैं कि जब कोई भी कारीगर जानता है ना, ग्लास को काटना होता है, पहले उस पर डायमंड से क्रैक लगाता है ना, और क्रैक लगाने के बाद तोड़ देता है उसको। दैट मींस दैट क्रैक इज गोइंग टू वीकन अ मटेरियल। और ये मटेरियल कौन सा है? ये सिंपल पॉलीमर है जो पैकेजिंग में आती है ना, हमारे जो कभी खाने का सामान वगैरह पैक करके आता है प्लास्टिक में, वो वाला प्लास्टिक है। और उस प्लास्टिक को अगर मैं अपने टीएफटी स्क्रीन के सामने रखूं, तो मुझे उसके स्ट्रेस फील्ड्स नजर आने शुरू होते हैं। तो स्ट्रेस होता है ना, जैसे इंसान में स्ट्रेस और मटेरियल में स्ट्रेस दिखता नहीं है, लेकिन डैमेज बहुत करता है। आपको मालूम है, इंसान में भी स्ट्रेस अंदर रहता है हमको, और वो क्या करता है, काफी डैमेज करता है हमारे को, है ना। मानसिक जो तनाव बोलते हैं ना हम लोग, और मैं अभी बता रहा था ना, काफी ओवर वर्कलोड की वजह से काफी मानसिक तनाव रहता है। तो इसी प्रकार से मटेरियल में भी स्ट्रेस होता है, और वो दिखता नहीं है। तो इसको देखने, स्ट्रेस देखने का एक बहुत सिंपल तरीका हो गया आपके पास, ठीक है। कि आपने देखा कि भाई देखिए ये मटेरियल है, उसमें मैंने क्रैक डाला तो उसके आगे स्ट्रेस फील्ड नजर आते हैं, उसको मैं खींच तोड़ के भी देख सकता हूँ कि कैसे स्ट्रेसेस दिखाई देते हैं। तो ये तो वो चीजों की दिखती नहीं है, आराम से दिख गई अभी, है ना। इसी प्रकार से हमने क्या किया, एक प्लास्टिक लिया, प्लास्टिक में एल्यूमिनियम को मेल्ट करके अंदर डाल दिया। कुछ एल्यूमिनियम मेल्ट करके डालने की जरूरत नहीं है, लेकिन आप अगेन देखेंगे कि इसके चारों तरफ इस प्लास्टिक में स्ट्रेसेस दिखाई देते हैं। तो एक बार दिखाई देने लगे तो फिर समझ में आएगा ये क्या कर सकता है, ये मटेरियल को क्या डैमेज कर सकता है, क्या कहते हैं अपने बॉडी को क्या कर सकता है वो। तो इसीलिए विजुअलाइजेशन इज वेरी वेरी इंपॉर्टेंट, अगर चाहे मटेरियल हो चाहे जो केमिस्ट्री के टॉपिक्स हो। मैं बोल रहा था कि मैं नेचर से कपल ऑफ एग्जांपल देना चाहता था। तो ये शेल है, ये शेल मोस्टली चूने से बना रहता है। ये हमारे मेराइन प्लांट होता है अबलोन, उसका शेल है। और अगर आप देखेंगे इस अबलोन शेल में तो आप देखेंगे कि 95% प्लस ये चूने से बना है, इनफैक्ट और भी ज्यादा परसेंटेज होगा। अगर ये चूने से बना है तो कैसी इसकी टफनेस कैसे इतनी ज्यादा है, टूटती क्यों नहीं है? क्योंकि एनिमल को प्रोटेक्ट करती है ना काफी, और अक्सर ये एनिमल जाकर रॉक से टकरा जाता है, ये वाला जो सी मोलस्क है, तो टूटता क्यों नहीं? तो इसके अंदर अगर आप इसको जरा थोड़ा ध्यान से अंदर की तरफ देखेंगे तो पाएंगे कि इसकी कंस्ट्रक्शन जैसे हमारे ब्रिक्स वगैरह हैं, जैसे एम्प्री में काफी ब्रिक्स वगैरह डेवलप होते हैं नए नए, और कंस्ट्रक्शन टेक्निक्स डेवलप होते हैं। तो आप देख रहे हैं कि ये जो ब्रिक्स से बना हुआ है, किसके ब्रिक्स? कैल्शियम कार्बोनेट के। लेकिन और इस ब्रिक्स के बीच में थोड़ा सा एक प्रोटीन होता है, और ये जो प्रोटीन है थोड़ा सा, वो इसको काफी टफनेस प्रदान करता है। टफनेस का मतलब काफी एनर्जी अब्सॉर्ब करता है टूटने से पहले। यानी कि हमारे पास नेचर में एक एग्जांपल है जिसकी कंस्ट्रक्शन हायरार्किकल है। हायरार्किकल का मतलब ऊपर से नीचे तक कई लेवल पे मुझे समझना पड़ता है, और ये सब एक सिंपल माइक्रोग्राफ में दिखाई दे जाता है कि क्यों, कैसा है इसका कंस्ट्रक्शन। ठीक है, तो नेचर में हमें कई सारी चीजें मिल जाती हैं जो कि काफी हमको इफेक्ट कर सकती हैं। लेकिन अगर मैं उसका थोड़ा एक विजुअल रूप करूं, इधर जैसे यहाँ पर मैंने किया है, या सिंपलर मॉडल हो जैसे मैंने बताया था अभी कि डोडेकाहेड्रन दिखा दूं, तो आसानी से समझ में आता है। इसी प्रकार से अगर आप देखेंगे एक कॉन्सेप्ट होता है कि अगर मैं पानी को मेल्टिंग पॉइंट से नीचे ले जाऊं तो फ्रीज नहीं होता, अक्सर फ्रीज हो सकता है, नहीं भी हो सकता है। अगर मान ले कि आप अमेरिका में हैं और -10 डिग्रीज बाहर है, आप वाटर बॉटल किनले के बाहर छोड़ दें तो अगले दिन पाएंगे कि 4-5 बॉटल फ्रीज हुए ही नहीं है। जब -10 डिग्रीज था तो फ्रीज क्यों नहीं हुआ पानी? तो इसके और फ्रीज कराने, जैसे हम लोग प्लेन देखते हैं ना ऊपर जाता है तो उसमें पीछे एक धुआं टाइप दिखता है, वो एक्चुअली हेट्रोजेनस न्यूक्लिएशन बोलते हैं उसको। तो आप देखेंगे ये हमारी सिमेट्री लैब का एस मैंने स्क्रैच किया है, उसमें अगर एफर्वेसेंट लिक्विड डालेंगे तो आप देखेंगे कि वो एस ऊपर अपीयर हो जाता है। तो इस एक्सपेरिमेंट का मकसद कुछ ज्यादा नहीं है, सिंपल है कि जब हम लोग हेट्रोजेनस न्यूक्लिएशन पढ़ते हैं कि भाई क्यों प्लेन के पीछे एक वो बना होता है, और कभी कभार हम क्लाउड सीडिंग की बात करते हैं कि भाई क्लाउड में हम लोग बारिश कराना चाहते हैं, तो क्या उसके पीछे कॉन्सेप्ट है? तो यही कॉन्सेप्ट है। अगर आप कभी बार देखेंगे कि अगर आप कोकोला पी रहे हैं और अगर स्ट्रॉ डालते हैं तो बबल्स कहाँ बनते हैं? स्ट्रॉ के आसपास बनते हैं, है ना। तो इसको समझने के लिए ये एक सिंपल एक्सपेरिमेंट है। लेकिन अगर आप वो कोकोला डालेंगे और कोकोला डालने के बाद उसमें थोड़ा चीनी डाल दिए, देखेंगे सारा का सारा कोकोला बॉयल ओवर हो जाएगा। तो स्टूडेंट क्या देखिएगा, अरे ये तो कुछ गड़बड़ हो रहा है, अभी तक तो सारा था, अचानक कहाँ से ये सब गैस आ गया? और अगर मैंने गैस को अंडर प्रेशराइज कर ही दिया, मतलब मैंने कोकोला कैन खोल ही दिया, तो सारी गैस निकलती क्यों नहीं है बाहर? धीरे धीरे करके क्यों निकलती है? अच्छी बात है, तभी तो फिज रहेगा थोड़ी देर के लिए कोकोला में। लेकिन अचानक कैसे निकल गई मैंने, अगर मैंने उसमें शुगर डाल दिया तो ये जब एक्सपेरिमेंट दिखता है तो इसमें सवाल ऑटोमेटिकली खड़े होने शुरू हो जाते हैं। और आजकल ऑल द मोर जरूरी है क्योंकि सिलेबस काफी वास्ट हो गया है। इसी प्रकार से आप देखेंगे लोटस लीफ होता है, उसमें पानी चिपकता नहीं है ना। तो आप देखेंगे कि उसमें जो उसके ऊपर पानी डालेंगे तो वो बह जाता है। तो उसकी भी अगर आप स्ट्रक्चर नीचे देखेंगे तो पिक्चर से दिखाई देती है कि उसके ऊपर काफी सारी जो माइक्रो प्रोट्रूशंस होती हैं और हायरार्किकल होती है। और इससे हमें क्या मिलता है कि ये इससे जो मिलता है, इसमें सुपर हाइड्रोफोबिसिटी मिलती है। यानी कि एक तरफ हम बिल्कुल एडवांस रिसर्च की बात कर रहे हैं, सुपर हाइड्रोफोबिसिटी की बात कर रहे हैं, और समझ कहां से मिल रही है हमको? सिंपल अपने लोटस लीफ से। और कैसे मिल रही है? कुछ पिक्चर्स देखें हम लोग, एक्चुअल पानी डाल के देखें उसके ऊपर, लोटस लीफ के ऊपर। भाई लोटस लीफ में पानी कैसे दिखता है, बनाना लीफ पे कैसे दिखता है ना। और ये सिंपल एक्सपेरिमेंट है, कोई ज्यादा मुश्किल नहीं। ग्लास पे कैसे दिखता है ना। तो हम लोग पानी डाल के देखें उस पर। तो ये जब एक्सपेरिमेंट करते हैं और ऑब्जर्व करते हैं तो तो हमें काफी समझ रहती है और समझ चिपकती है। ठीक है, तो ये हो गया कुछ। और मैं सिर्फ एक लास्ट एक, क्योंकि काफी हम लेट चल रहे हैं, तो एक मैं आपको एक्सपेरिमेंट दिखा देता हूँ जो मैं बता रहा था ना पानी के बारे में। तो ये आपको स्क्रीन दिख रहा है एक वीडियो का?
ये सर दिख रहा
एक
है। हाँ।
मैंने एक सिलेंडर रखा हुआ है, सिलेंडर के
Yes,
अंदर
sir.
कुछ लिक्विड है, तरल पदार्थ है। तो मैं इस वीडियो को प्ले करता हूँ, अगर प्ले हो रहा है तो देखिए। तो मैं क्या कर रहा हूँ, कुछ ज्यादा कुछ नहीं, एक तरल पदार्थ है और उसमें मैं क्या कर रहा हूँ कि एक कुछ सॉलिड डाल रहा हूँ। ये सॉलिड ऑफ कोर्स सोडियम, ये लिक्विड सोडियम एसिटेट है, वो सॉलिड भी सोडियम एसिटेट है। सोडियम एसिटेट ये कुछ और भी सॉलिड डाल सकता था उसके ऊपर। तो ये जो प्रोसेस चल रहा है इसको डायरेक्शनल सॉलिडिफिकेशन बोलते हैं। वैसे देखा जाए लगता, और हमारे जो प्लेन के कभी कभार जो गैस टर्बाइन के इंजन होते हैं उसके जो ब्लेड्स होते हैं डायरेक्शनल सॉलिडिफिकेशन से वो बनाते हैं। ठीक है, उसकी वजह मैं यहाँ नहीं बताऊंगा, लेकिन लगता काफी एडवांस चीज है। लेकिन हम अपने सिंपल एक्सपेरिमेंट कर सकते हैं। और सवाल इस एक्सपेरिमेंट में क्या है कि मैंने जैसे बताया ना, पानी मेल्टिंग पॉइंट के नीचे रहता है फिर भी वो आइस नहीं बनता है। तो इसी तरह से सोडियम एसिटेट मोल्टन कंडीशन में, ये मोल्टन है फिर भी ये सॉलिड नहीं बना। तो सवाल उठता है मेल्टिंग पॉइंट, और तो हम जानते हैं अरे भाई अगर आप जब हीट करेंगे तो आइस मेल्टिंग पॉइंट में मेल्ट हो जाएगा, और जब ऊपर से कूल करेंगे तो मेल्टिंग पॉइंट के नीचे फ्रीज हो जाएगा। ये हमारी समझ है। तो असली समझ ये है कि मेल्टिंग पॉइंट होता है लेकिन फ्रीजिंग पॉइंट नहीं होता है। मेल्टिंग पॉइंट इज नॉट द सेम एज फ्रीजिंग पॉइंट। एक बहुत क्या बोलते हैं ना कि सिंपल सा कॉन्सेप्ट लग रहा है मेल्टिंग पॉइंट। तो यहां पर एक वीडियो में हमने देख लिया कि अगर मेल्टिंग पॉइंट के नीचे भी सामान रह सकता है, मोल्टन लिक्विड रह सकता है, लेकिन अगर मैंने एक छोटा सा उसमें न्यूक्लिएशन डाल दिया तो सॉलिडिफिकेशन स्टार्ट हो जाती है, और इसको हेटेरोजेनस न्यूक्लिएशन बोलते हैं। तो इनफैक्ट परसों ही हमारे एक इस न्यूक्लिएशन पर एक हमारे कलीग हैं जिन्होंने फिजिकल रेगुलेटर्स पेपर छापा है, तो उस पर उन्होंने टॉक दिया, प्रेजेंटेशन दिया। तो अक्रॉस द कंट्री लोगों ने उस पर पार्टिसिपेट किया। तो ये न्यूक्लिएशन ही था, वो उसका पूरा ये था कि लिक्विड में शेयर जब होता है तो शेयर से न्यूक्लिएशन कैसे हो सकता है। तो आपने देख लिया ये। अब सवाल उठता है कि अब वीडियोस कैसे बनाए जाए, है ना। अगर हम स्टूडेंट्स को दिखाना चाहते हैं तो एक गलती कभी ना करें, ये सोचे कि सर सारे वीडियोस तो अवेलेबल हैं नेट पे, स्टूडेंट्स खुद ही देख लेंगे। क्योंकि आजकल इंफॉर्मेशन ओवरलोड है, स्टूडेंट्स खुद ही नहीं देख पाएंगे, आपको उनमें से छांटना पड़ेगा एक दो वीडियोस। और जैसे मैं फॉर इंस्टेंस एक यूट्यूब के ऑथर है साइंस असाइलम, उनका वीडियो है कि कैसे कैपेसिटर काम करता है। हम स्कूल में पढ़ते हैं 11th 12th में कैपेसिटर के बारे में, कैपेसिटर में एनर्जी फ्लो कैसे होता है। बैटरी जब ऑन करते हैं तो करंट, वो क्या चीज है जो एनर्जी को पहुंचाता है वहां पर, क्या वो इलेक्ट्रॉन्स का फ्लो है, क्या इलेक्ट्रॉन फ्लो होके जाके बैटरी वो बल्ब के अंदर जाएगा। सिंपल सा सवाल लगता है सुनने में कि भाई यार बैटरी तो ऑन किया मैंने, इलेक्ट्रॉन जाएगा बल्ब के थ्रू और वो बल्ब को जलाएगा। लेकिन आप देखेंगे आधा एक घंटा लग जाता है वो इलेक्ट्रॉन को पहुंचते पहुंचते, उसकी ड्रिफ्ट वेलोसिटी बहुत छोटी होती है, वो बल्ब तक पहुंचते पहुंचते आधे घंटा हो जाएगा। तो क्या एक घंटे के बाद बल्ब जलता है? नहीं जलता है। बल्ब तो इंस्टेंटेनियसली जलता है, प्रैक्टिकली किस स्पीड पे जलता है। तो करंट कैसे पहुंचता है, सिग्नल बैटरी से बल्ब तक कैसे पहुंचता है। तो लगता है बहुत ट्रिवियल सवाल पूछ रहे हैं, लेकिन इसकी समझ काफी डीप है ना। और इस पर बहुत अच्छे वीडियोस हैं यूट्यूब में। तो अगर आप उन वीडियोस को छांट के, जैसे मैंने एग्जांपल दिया साइंस असाइलम का, एक और साहब वेरिटासियम के साहब हैं, उन्होंने भी वेरिटासियम करके वीडियो बोलते हैं। और वेरिटासियम का मतलब है, ही सेज इट्स एन एलिमेंट ऑफ ट्रूथ। वेरिटासियम को एलिमेंट नहीं है, ही कॉल्स इट द एलिमेंट ऑफ ट्रूथ। ओके, तो उसके वीडियोस हैं कि इसी बल्ब जलने पर, उन्होंने एक सवाल उठाया, इसी बल्ब जलने पर एक से ज्यादा वीडियोस हैं, और वो सारे एक बार टटोल देते हैं आपके ज्ञान को कि भाई व्हाट इज हैपनिंग, डू आई अंडरस्टैंड कैपेसिटर्स, डू आई अंडरस्टैंड बल्ब्स glowing because of simple battery connection, do you understand the electron flow, what is the rate at which electrons are flowing, why signal is traveling at a different speed than the electron flow, what is the relevant distance in this, right। तो ये सब सवाल के जवाब हैं YouTube में। तो अगर आप इन YouTube के वीडियोस को छांटे और जैसे मैंने बताया सिंपल मॉडल्स बनाए टेट्राहीड्रन के लैब में, स्टूडेंट से कुछ करवाएं, मतलब जैसे इत्तेफाक से मैंने कभी 6th स्टैंडर्ड 7th स्टैंडर्ड और 8th स्टैंडर्ड के स्टूडेंट्स को पढ़ा रहा था, स्कूल के बच्चों को मैं पढ़ा रहा था एज ए टीचर। तो उस वक्त क्या हुआ कि मैं बताता बच्चों को, बच्चों आप सोचिएगा, थिंक, डू नॉट मग अप, थिंक, मेमोराइज ना करें, थिंक करें, ये मैं बोलता गया। तो 8वीं कक्षा की एक बच्ची ने उठ के मुझसे सवाल पूछा, ये बहुत डिकेड्स पहले की बात है, सर व्हाट इज थिंकिंग। सवाल पूछ लिया मुझसे, सर व्हाट इज थिंकिंग, यही सवाल पूछा स्टूडेंट ने। तो ये हमारा सिस्टम जो हो गया है इंडिया का, काफी कबार थिंकिंग से ज्यादा मेमोरी पर ज्यादा ध्यान देता है। और मैं कोई नई बात तो बता नहीं रहा, 3 इडियट्स मूवी में है सब। तो so when we want to think and learn, I think the best methods are models, experiments, and whereas teachers, if you're not able to access these experiments made by yourself, अगर आप खुद एक्सपेरिमेंट करने में आपके पास फैसिलिटीज नहीं है, लैब नहीं है, तो ऐसा ना सोचे कि नहीं है। यूट्यूब में काफी अवेलेबल है, लेकिन यूट्यूब में इतना सारा अवेलेबल है कि ओवरलोड हो जाता है स्टूडेंट्स पे। तो आपको क्या करना है कि आपको उसको, उन वीडियोस को छांटना है और स्टूडेंट्स के सामने प्रस्तुत करना है। With these few words, I thank you all for your kind attention, and I hope that we all learn together and we keep learning so that we feel happy about learning, and in the process the students also learn. So thank you very much all the teachers, and I especially thank the AMPRI people for inviting me and giving me this opportunity. As I said, I have deep connect both with KV, AMPRI, and the whole system. Thank you very much.
Thank you, sir.
Thank you so much, sir.
Thank you, Professor Anand Subramaniam. मॉडल एक्सपेरिमेंट्स ई वीडियो से हम कैसे बेस्ट लर्न कर सकते हैं, दिस इज वॉज रियली वेरी सिंपल एंड वेरी वेरी यूजफुल टॉक, स्पेशली द ऑडियंसेस हु आर प्रेजेंट हियर। तो जो टीचर्स यहाँ पे प्रेजेंट हैं, इंक्लूडिंग फैकल्टीज जैसे हम लोग हैं, ये एक बहुत अच्छा प्लेटफॉर्म था जो कि कैसे कॉम्प्लिकेटेड चीज़ें जो दिखती हैं उन्हें मॉडल से हम बच्चों को सिखा सकते हैं। एंड आई एम वेरी श्योर वी विल बी ट्राइंग टू इम्प्लीमेंट टू द स्टूडेंट। सो नाउ we are already running out of time, but if someone is having questions, we can have quickly 1 or 2 questions also from Professor Anand Subramaniam. So they can raise hand.
इसमें वीडियो नहीं आ रहा, पता नहीं कैसे ट्रेनिंग में ऑडियो दब गया। तो ट्रेनिंग बहुत बार सब चल रही है, उसमें जो है वो आवाज।
Is anyone having some question from Professor Subramaniam? So so we will go ahead with the program. We are really honored to have Professor Sunil Kumar Singh, Director CSIR NIU Goa, a well-renowned geochemist with us today. Sir, before I invite you, I will take privilege to introduce to the gathering, and you have very long list of achievements, so I have tried to summarize, but it is going to take some time. So Professor Sunil Kumar Singh has his master's from Banaras Hindu University and PhD from Physical Research Laboratory, Ahmedabad. He worked at CRPH CNRS Nancy, France for 3 years as a postdoctoral fellow, and then he moved to India and worked in different academic capacity at Physical Research Laboratory till May 2017, and then from June 2017 he is a director at CSIR-NIU Goa, where currently he is serving in the same capacity. Professor Singh's research interest is really very interesting, and it's basically biogeochemistry of trace elements and isotopes in Indian and Southern oceans and Indian estuaries, low temperature elemental and isotope geochemistry, and so on. I have to say that his research has played a very important role in understanding the evolution of the Himalaya and its role in modulating the long-term global climate. Professor Sunil Kumar Singh has more than 70 scientific publications to his credit. He is member of editorial board of number of international scientific journal, guiding number of PhD students and postdoctoral fellows. He is also a member of number of national and international academic committee and elected fellow of all 3 science academics in India: the National Academy of Science, India, Allahabad; the Indian National Science Academy, Delhi; Indian Academy of Science, Bangalore. He has been recipient of number of awards like National Geoscience Award 2012, Eminent Mass Spectrometrist Award 2015, and as Dr. Sadanand Mishra already mentioned, the most prestigious award for Science in India, Shanti Swarup Bhatnagar Award 2016 in Earth, Atmosphere, Ocean, and the Planetary Science. As I mentioned, there is already a very long list, but because of time constraint, I will stop here myself. And we are really looking forward to hear you, sir, on the topic Blue Economy, Scientific Science, and the Technological Interactions. Sir, please.
Thank you very much, Dr. Archana Singh ji. At the outset, I would like to thank organizers, particularly Dr. Avnish Srivastava ji and Dr. Sadanand Misra ji for giving me this opportunity to interact with all the teachers. Professor Anand Subramaniam ji, I think it was a fantastic talk. Very simply, you have shown how the complex subject can be taught with very simple experiments and all. I think it was really, really very innovative, and we learned a lot. And I think such type of talks should be arranged more and more for the teachers. So, dear teachers of Kendriya Vidyalaya, Navodaya Vidyalaya students, ladies and gentlemen, actually I was not privileged enough to study in Kendriya Vidyalaya because we come from a village where even those days school buildings were not there. We are studying under banyan tree or something. When it is raining, we have to run go to the houses and all. So I think it was a fun to do all those things. And actually, when we came first time to Banaras, then we saw the electricity and all. So it was a very different kind of experience we had. And so I think that is the India actually. The India means, you know, so diverse it is. From one end you have this type of school, if you have another end you have very different kind of school. So this is the Kendriya Vidyalaya, in fact, and Navodaya Vidyalaya, where people are teaching a lot of things to their students, culture and all the social value and all. But I think science is also very, very important, because when we are talking about the 5 trillion 5 trillion economy for the India, I think we have to talk about science. So I'm going to talk something about blue economy, which is very, very important in terms of when you were talking this, as our director Shah was telling Avnish Srivastava ji about this Atmanirbhar Bharat, and you have to self-sufficient in our economy. When we are talking about the 5 trillion economy, blue economy is very, very important. And recently, Government of India has started Deep Ocean Mission to boost this blue economy. And hence, I think it will be good to tell our teachers about this blue economy, how science and technology is going to change the entire scenario. And also, I think it is very much important for our teachers coming from Navodaya Vidyalaya and Kendriya Vidyalaya to tell the students how important this subject is. And I think it is very much, I think, lucrative for the students to take this oceanography as a career. So what I'm going to do, I think in the beginning, I will tell a little bit about oceanography, what it is and how the oceans are evolving, from where it is originated. Because I know it is a little bit new subject for even teachers. So a little bit I'll be telling about that. And then I will tell about the blue economy, what are how ocean is important from the economic point of view, what we can do for that. So here, if you see ocean, everybody knows that this is, we are taught in the schools that 71% of the Earth's surface is covered by ocean. And I think the total area of all the oceans, if you see on our globe, it is about almost 361 million square kilometer. Out of that, Indian Ocean is about 71 million square kilometer, almost 17-18% of the total ocean area. And it contains, 97% of the Earth water with a volume of 1.35 billion cubic meter. The more important or most important part of the ocean is it controls the carbon cycle. So whatever today we are having this CO2 and all those controls, whatever you have within a limit which human can sustain that CO2, it's all because of ocean. And 90% of the Earth biosphere is comprised of this ocean biology. And it is very important that it controls the climate and weather pattern of the entire globe. And so many species are there that only we are able, till now we are able to study only part of that, only maybe 2 or 3 or 4% of the ocean we have studied about the biological species, and also a lot of things has to be done in this regard. And hence it is very much important for our teachers to convey this message to the students that how ocean is important. So as you are all aware, whatever oxygen we breathe today, 50% comes from the ocean. So ocean, when you have this productivity, they during the photosynthesis, they convert this the CO2 and light, taking the help of light, they convert it to oxygen. So that oxygen we breathe. So 50% of that comes from ocean. And also, as I was telling you, 71% of the Earth's surface area is covered by ocean. They regulate the climate. Actually, because the solar radiation which we are getting on the Earth is not uniform. The equator we are getting much more, and polar region is much less. And hence it is the ocean which is transporting the heat from equator to the polar region. And again, also the ocean is distributing entire the nutrients, the food supply to the ocean. Also, ocean is very, very important for the food, what we are eating. I think we depend heavily on the ocean for the food, the protein, the medicines. You can tell so many actually things. Today itself means if you see the global economy depends heavily on the ocean. So ocean is very, very important for this regard. And in addition to that, as you know, this ocean is a very integral part of our Earth system science. So it is very much important to study the ocean, because they control the fisheries. This is a very important food for the global people, people, also the proteins. It controls the ship, means it is very much important for the shipping, because almost 80 to 90% of the transport is happening through shipping. Coastal means then again you have to work, our coastal areas are vulnerable. It is also a very attractive attraction for the tourism. So that matter is very, very important locally. But if you talk about global scenario, it is impacting the climate and climate change. Similarly, like it is impacting our monsoon, and our economy is very much dependent on monsoon. So hence, it is very important to study the ocean, because if you want to predict the monsoon on long-term scale, it is very much important, or it is almost imperative that you have to study the ocean. Unless you have the good knowledge of ocean, it's impossible to study or predict the monsoon. So it's so intricate relationship with monsoon or climate with ocean that you can avoid that. And now you know that because of anthropogenic activity, this climate is changing, temperature is increasing, and ocean is getting acidified. The pH is decreasing in the ocean, and we have sea level is rising. And also because on the land we are utilizing huge amount of fertilizers, and all part of that nutrients are going to the ocean, and coastal oceans are becoming eutrophication is taking place. And similarly, we are polluting a lot of part of the ocean. So there is a need to study that, because as you know, that it is our global temperature is increasing continuously, and since industrialization, almost 1 degree temperature increase has taken place. And in that, if you see the 93 or more than 90% of the heat which is getting generated because of man-made activity, it is going to the ocean. And because of that, the sea level or sea temperature is increasing significantly. And if you see last almost 60 years record, or ocean record, it has changed by about 0.7 degree centigrade. But Indian Ocean particularly, if you see, it has increased by 1 degree centigrade. So it's really worrisome, because the top 3 meter of the heat contained in the top 3 meter of the ocean, it is much more than atmospheric total energy. And hence, when we are increasing that, it is very much impacting the climatic pattern, like cyclonic activity will be increasing, like extreme weather will be increasing, extreme rainfall will be happening. So this is all very much related to this global warming, and hence it is very much important to study. Similarly, as you are increasing the temperature because of thermal expansion and because of the ice melting, this glacier melting, the sea level is increasing, and once sea level is increasing, the average right now is 3.3 mm per year. But this increase will be impacting the coastal area significantly. Like, people predict that within 50 years, means this is all my model prediction, that part of the Bombay or part of the Bangladesh will be submerged So this is the type of scenario is emerging because of this global change. So there is a need to study ocean very actually there is an urgent need to study. Similarly, if you see that means it's a natural phenomena also. The sea level has keep on rising and going down. And if you see compare our today's sea level with the say 20,000 year before, the almost sea level was down by 130 meters. So sea level at last glacial maximum, that is 20,000 years before, was almost 130 meters below what we see today. So you know that area of India was much bigger. So that was the reason actually, you know, the Dwarka and all, you know that part of the Dwarka is submerged. That is because of this natural phenomena. Because those days, earlier, all our coastal areas where we see the water, it was exposed, and the city means people were thriving there, staying there. But because of the sea level right now, it is down. So part of the Krishna, that Edo, that Dwarka has gone inside the ocean because of the sea level increase, which is happening because of, but it is not related to the anthropogenic activity, it is natural phenomena. And also because of this warming, you know, acidification is taking place, and also because of the warming, the solubility of oxygen is decreasing. So the almost 2% oxygen is lost between 1960 and 2010 in the ocean. So this again will be having a lot of problem when if you are going to remove the oxygen from the ocean because of the global warming. So I too, you know, means all the why ocean is important, why it is important to study the ocean. So first I will tell you a little bit about the ocean, from where it came, how it evolved. So this is a very typical figure you must have seen in the since the beginning of the Earth formation. So this is, you know, Earth got formed at 4.56 billion year. We have now these ages are very reliable ages are available. So we know very much sure that our Earth is means originated at about 4.56 billion year, and soon after that Moon was formed. So Moon just because there are a lot of hypotheses why Moon was formed, but people think that in the beginning when Earth was forming, a lot of bombarding of meteorites and asteroids was taking place, and part of that has created the Moon. But you know, Moon formation has very important impact on the Earth, because before Moon was formed, Earth was rotating, but it was wobbling a lot, and also because of Moon formation, the Earth got inclined, and you know that inclination of the Earth is very much important for the seasonality, and you know that because of seasonality, how important the seasonality is in context of our human development. But the main question is how from where the ocean water has come. So if you see that till now the study which has been taken place, the ocean got completely formed by 3.8 billion years. Whatever ocean is today, you see shapes are changing, keep on changing because Earth is dynamic, plate tectonics is happening. But we know that Earth means the ocean got formed by 3.8 billion years. But at the same time, we also know that in the beginning there was no oxygen in the atmosphere, there was no oxygen in the water, hence a very different kind of life was existing in the ocean. And about 2.7 billion years back, a very important incident took place when the algae, the blue-green algae, the cyanobacteria, they learned the art of photosynthesis, and since then oxygen started to come to the atmosphere, to the ocean, come to the ocean, and hence then since then oxygen is increasing in the ocean, and life got very different kind of life was evolved. So this is what I wanted to tell you. So this is the early Earth when a lot of bombarding was taking place, and those asteroid or those whatever material was accreting to the on the Earth, they were bringing a lot of water molecule with them. And when the Earth was getting initially very hot and all, lot of degassing was taking place. The interior of the Earth was giving your helium, CO2, H2O vapor, but the atmospheric temperature was very high, almost about 2,500 Kelvin. So this water vapor was not able to condense, and hydrogen and helium, they were escaping to the space. But CO2 was remaining in the atmosphere, and temperature was very high. But slowly it started cooling because of release of heat, and hence water started to precipitate on the Earth, and hence this water started to accumulate as a part of the ocean. So based on some study, people have found that what is the source of this water. And almost now it is has been shown isotopically that most of the water is coming from carbonaceous chondrites. It's not coming from protosolar nebula. It is not coming from comets, because some of the comets, they contain 25-30% of the water icy comets when they were interacting with the early Earth, but they are not the major source. Major source are carbonaceous chondrites, which has brought this water to the Earth. And timing, if you see timing, actually this timings information about the Earth history I preserved in the sedimentary rocks, but very old sedimentary rocks are not preserved. So people rely on a very special mineral called zircon. And zircon isotopic study has shown that the first trace of the water came on the Earth is about 4.4 or 4.3 billion years back. So the means water already was there just after 200 million year of the Earth formation. It started to come on the water Earth, and since then it was started accumulating, and by 3.8 billion year the entire ocean was formed. So this is the history you can see. And once you are having the CO2 in the beginning, as I told you, CO2 level was very, very high. The water was very acidic, so very different. Means life was very tough. But because of weathering and all, CO2 started to decrease in the ocean, and again going back to the mantle. So CO2 is going down and pH is increasing. So today pH 8.2. But again, since this global warming and CO2 increase in the atmosphere, this pH is going down, and now many places it is 8.1 or something like that. So people are worried about that. But this is the whole story of in the beginning. And then above that is this ocean circulation. The global ocean circulation is very, very important to, as I was telling you, equatorial region gets more heat in the Earth, and polar region are getting less heat. So this ocean circulation, the deep water is forming in the polar region. So deep water, this blue line you can see. So the deep water, say like 3 kilometer, 4 kilometer deeper water is moving and coming towards equator and coming towards Antarctica. And then part of that is coming to the Indian Ocean, and remaining is going to the Pacific. And again, in the equatorial region, this whole water is coming to the surface, and as a surface water from Pacific, it is coming to the Indian Ocean, and that Indian Ocean also, the water which is coming here, it is called the Indonesian through flow, and then it is going to the Atlantic as a Agulhas current, and whole cycle is getting completed. And in this process, it is taking heat from equator and putting in the polar region. So on one estimate, it has been estimated that if because of some reason you will stop this ocean circulation, the polar ice will increase significantly. It can cover entire Europe if you stop this ocean circulation. And also this ocean circulation distribute a lot of nutrients and food to the entire global ocean to thrive the biology in the ocean. So I don't know whether we are able to see this. This is the ocean circulation movie. You can see here how it is moving. The deep water is forming actually here. You see this area, deep water is forming. It will go all together, come to the different part of the globe and come to the equatorial region, and then just whether it is going a little faster. So the deep water is forming in this area, and slowly it will move and it will come to the Indian Ocean from the Atlantic. So here you can see in Indian Ocean, this deep water is coming to getting a swell and upwell in the surface water, and again you see this going part of that is going to the Pacific and coming back. So all together this water will be going back to the Atlantic. Another water movement is because of the earth circulation. Always it is happening in circumpolar current, which is covering this Antarctica. So all together, this ocean circulation, this is global conveyor belt, is very, very important to transport heat and all those things. That's what I wanted to convey. Another thing which is very much important which is controlling the CO2 level in the atmosphere is this biological pump. So as I was telling you, because of photosynthesis in the photic zone where light is penetrating, life is growing, and different microorganisms like phytoplankton, and small phytoplankton, calcareous animals, siliceous animals, they grow in this part. They consume CO2, they make the organic body, and then that will be eaten by zooplankton, and then it will be eaten by fish. And part of the CO2 will be coming to the atmosphere. The part of that, which is very important, goes to the sediment, and it will be buried in the sediment, and the same sediment will be going, because of plate tectonics, will be going to the mantle. So the whole CO2 level is controlled because of that. And And if you stop this biological pump due to some reason, the atmospheric CO2 will increase suddenly. Today you have 400 ppmv, it will immediately become almost 700 to 800 ppmv, and you can imagine how difficult it will be to survive on the ground. So this biological pump is very much important to control the CO2 level. Now, the ocean chemistry, as I was telling you, a lot of chemicals are present in the seawater, the pH, and I have shown you how it has changed. But similarly, in the beginning, oxygen was not there. A lot of iron was coming to the ocean through the this hydrothermal vents, and because of that, oxygen was not there. So it was always in the +2 oxidation in dissolved form. And hence, ocean was looking like this. The iron concentration was very, very high in the ocean during those days. Means when oxygen was not there, say about 3 billion years before, and life was very different because this type of mineral was just staying there, surviving there. So if you can see the Indian Ocean is very, very important in this regard, because Indian Ocean is very different compared to Pacific and Atlantic, because Pacific and Atlantic Ocean are from pole to pole, where Indian Ocean you can see that it is a landlocked in the low latitude. So because of that, the ocean circulation, which I showed you some time back, it is not going from pole to pole. So as the deep water is coming towards the north side, it is becoming slow. And because of that, it is not able to bring a lot of oxygen to this area. And hence, the intermediate water of this northern Indian Ocean, oxygen is very, very low. So oxygen is becoming so low that during the monsoon, this low oxygen water is coming to the coastal area, and sometimes tons of fishes are getting killed every year because of this low oxygen. So this is a natural phenomena. In Goa, in the monsoon season, one day suddenly in the morning or evening, you can see tons of fishes are lying on the beach. That is because this low oxygen area. Similarly, means a lot of very important thing is happening in the Indian Ocean, which I will not go in detail here. So what I'm telling is that, as I was telling, oceans are very important, and they are very good source of many of the resources. So like there are two kind of resources, living and non-living resources. So living is like fishes and all, that is very much important. They are supplying food. But in addition to that, they are also supplying a lot of minerals and energy sources and all. So some of them are like polymetallic nodule, and this gas I will come a little bit in detail. So here is the profile of ocean. You can see here in the beginning, if you see in the beach area and all, we get a lot of placer deposit where you have heavy minerals, uranium, thorium deposits are there. And then in slope shelf area, you get a lot of crude oil, natural gas, and in addition to that, we are getting this gas sided, the clathrates, which is the solidified methane. A huge deposit is there all over the shelf area. And as you are going further down in the plane, a abyssal plane it is called, we are having model, this manganese nodules. You see this type of cauliflower type of balls are available everywhere, and they are rich in manganese, cobalt, and so many other things. And then coming back to this this hydrothermal area, a lot of sulfide, very important minerals like platinum group elements and rare earth elements are deposited there. So India is working on, or even our institute is working on to explore these polymetallic nodules, and we are working in this particular area. And here we have, particularly in this area we are working, and we have been given, we have been identified as a pioneer partner to do this. So this is the area where India has worked, and you can see this, the entire 3 million square kilometer we have worked in this area, where right now we have given permission to do first generation mining site for 18,000 kilometers. So these are the ships were involved in do this polymetallic nodule study, and this type of operation was taking place. So we are lowering down and collecting a lot of sediment from the surface in the Central Indian Ocean, and a lot of modern nodules were getting collected like this. So you can see here, these are the nodules. A small ball kind of thing, kidney balls kind of things are getting accumulated, and this takes huge amount of time, because there is iron in the seawater, and as oxygen is available, this will be precipitating as iron manganese hydroxide, and slowly they will be forming. As soon as they are getting some nucleus, they will be started depositing, and in millennia time scale, they get become this bigger size, and hence we get a lot of these polymetallic nodules. So total, if you see the area which you have studied till now, the total 104 million metric ton of total reservoir metal we have explored, and where manganese 95, nickel is almost 5 million metric ton, copper is 5 million metric ton, and cobalt actually we have got. You know, the cobalt is not available now online, and cobalt is going to be very, very important when we are talking about electric vehicle and all. So this is some very important minerals are available. So what now under deep ocean mission, government is trying to, our different laboratories are trying to develop the techniques to how to extract that, because the nodules are lying 5 kilometers below the sea surface. So we have to have this trawler kind of thing and pulverize the material and then pump everything to the seaside. So this is the people are trying to develop some technology for that. And then we have some metal sulfide. So this is the mid-oceanic ridges, you know, where from the plate tectonics, you know, two plates are moving away and a lot of material is coming from down. And there we are getting this type of deposits. You see the black smokers and all, they are from the interior of the earth. They are bringing a lot of metal sulfides. So you can get platinum group element like gold and platinum and all. They are deposited in along this ridges. So there is a program to explore this also under the polymetallic, deep ocean mission, and government is trying to do that. And this is the cobalt crust which we are trying to extract. And then the another energy source which I was trying to tell you, this gas hydrate. Gas hydrate is nothing but the frozen methane. So below the 1,000 meter water in the coastal area, within the sediment from 3 meter to 50 meter, 60 meter sediments, this methane has been solidified because of temperature and pressure. And if you take 1 cubic meter of hydrate, if it melts, it will give you 164 cubic meter of gas. So it has a huge potential, and we have studied in all the coastal areas, and it has been found that almost huge deposit of this gases are there, and almost totally, if you see conservative estimate in these basins has been given of 933 trillion cubic feet gas is there, this methane hydrates. So if we are able to extract even 10% of that, next 10 year, 100 year, we don't need any energy source. But only problem is how to extract. We don't have the technology to extract that. We are trying to work on some of the technology like just depressurizing, so free gas can come to the atmosphere. But then we have to contain that, because methane is a very, very potent greenhouse gas. So it should not go to the atmosphere. Similarly, also there is people are trying to do that, putting the steam hot water so that the glaciers can melt and gas can come out. But again, controlled experiment is required. And then people are also trying to put CO2, because you know what is happening. We are worried about CO2. Our power plants and all are producing a lot of CO2. So there is a problem of sequestration of this carbon dioxide coming from power plant. So there is a plan, or there is a plan that the CO2 coming from our electric plant, they can be pumped inside to depressurize and push all the methane outside, so that this methane can be utilized as an energy source. At the same time, CO2 can be sequestered. So these are some techniques still we are working on. And I think first time Japan and China, they have tried to extract this methane. Means they have almost worked for 1 month continuously. They have extracted without much problem. So here are some photographs. You can see this. Japan and China, they have tried to extract these clathrates, but still commercial level, nowhere it is getting place. But in India also, we are trying to do that, how to extract that. And for that, actually, different technology are being developed for both polymetallic nodule, and this is for gas hydrate. Some of the technology like remotely operated vessels we are creating, and also the this manned submersible, which deep ocean mission they are trying to do, that they will go with man, they will, like Samudrayan, they will go to the interior of the earth and collect samples and see exactly where those hydrothermal plumes are there. In addition to these energy sources, actually this ocean is having a tremendous source of another green energy, like different part of the energy are coming. So here you can see the total energy from the ocean actually in forms of tidal energy, marine current power, osmotic power, because of the salinity difference. One side river is giving you 0 salinity and seawater is 35 salinity. So wherever they are meeting, the power can be created because of osmotic power. And then because of tide, because of marine current, you can produce a lot of heat. So altogether, ocean has a potential of 80,000 terawatt hour of energy in the ocean in form of tide, current, wave, and ocean heat, because the surface heat is 25 degrees centigrade, and as you go 1 kilometer down, it will become 5 degrees centigrade. So 20-degree difference is there. Because of that difference, also we can create huge amount of energy. So this energy, if you harvest, this will be completely green energy. And actually, if you see the base wave energy, how it has been produced, just by movement of these buoys, we can create like here it has been explained, because of wave nature, and this generator can be put, and because of up and down movement, you can create energy. Similarly, the tidal energy, because of sun, earth, and moon position, we create this tidal energy, and because of that, we can just put this tidal barrages and tidal fences and turbines, and you can create a lot of energy. Similarly, this ocean thermal energy, as I was telling you, this you put this simple very system to run the turbine through evaporating the ammonia gas by the surface water. Surface water 26 degrees centigrade, ammonia can be evaporated and run the turbine. And you can take the deeper water from 1 kilometer and cool this ammonia and again send back. So this is a closed system and keep on creating the ocean thermal energy. So this is called OTEC. And this type of system we have one in India, in Lakshadweep, which is producing a lot of water. Similarly, this wind energy can be tapped from the ocean. We can have floating this wind turbine in the ocean, and also the hydrogen, because you know that as you have seen this, our Subramaniam is working on green energy, hydrogen energy. So here, as you know, we have wind energy, we can have solar energy, so that we can utilize to generate, convert this hydrogen, and it will be totally green hydrogen. So this containers can be put on platform, and that can be converted. The seawater can be taken, and through electrolysis, we can produce hydrogen, which will totally green in nature, because you using solar energy and all. So there is a plan in India to harness this energy, and we have studied on how much energy they can have. So if you see here, the total coastal energy in terms of tide, it is 41 gigawatt in the coastal energy we have potential. And this type of wave energy, first time in near the Trivandrum, they have put one plant long in 90s, and now they are going to put a floating 1 megawatt plant in plant of the wave energy harvesting in the same area. Similarly, government is trying to put the potential of this wind energy to put a fixed platform in the Gulf of Cambay and near the this Gulf of Mannar, because a lot of potential is there. So they are trying to put this energy, harvest this energy. And also we have almost 8 gigawatt energy can be produced every year through the tidal energy. This is the potential has been estimated. So that also, and then we have our exclusive economic zone, almost 2.2 million square kilometers. So that can be utilized for putting the floating solar panels, because we land, it will be very difficult to put that much area. So this total capacity of this our exclusive economic zone is almost 10 terawatt per hour. 10,000 terawatt hour energy resource can be harvested from the solar energy. So this type of system actually we are trying to put, where wave energy can be utilized, the solar panel can be utilized, and on the same we can have wind channel. So altogether, this type of hybrid platform can be put. And in addition to that, above that, we can put the hydrogen energy system. So it will be a complete system which will be giving a lot of energy. So I thank you very much, and I tried to put together what type of resources are there in the ocean which will be helping in the for the blue economy. Thank you very much.
Thank you so much, sir.
Thank you so much, sir.
I have to admit that your journey, as you mentioned, from under the banyan tree to BHU to Bhatnagar Award and to current position is really inspiring, and I really congratulate for all your achievements, sir. And thank you so much for your presentation showing importance of oceanography, how it is important for existence of life, where it is providing 50% of oxygen, and then how it controls economy by controlling monsoons, where evolution of ocean, and most interestingly, when 70% of Earth is covered by water, and out of that 96% is covered by ocean, and out of that only 3 to 4% has been studied. So I am very sure that the teachers who are present, and even the students, if they are present, they will know the importance of oceanography, and this will be a very interesting talk for all of them. Thank you so much, sir, for your talk. So if someone is having questions, we can take quick 1 or 2 questions from audiences. Is anyone having questions? If no one is having, I am having one query. That's you showed that there is a particular direction of deep water in circulation. So I was just wondering whether this direction always remain maintained, and what are the factors that maintain this direction?
Actually, that is a very good question. Actually, this direction keeps on changing because of plate movement. You know, our top, if you see the Earth, the top 70 kilometer of the Earth plate keeps on moving. So ocean configuration keeps on changing. So this ocean currents keeps on changing the direction on the million-year time scale, not today time scale. So today it is fixed because what is happening in the polar region, because temperature is low, so whatever water is coming, ice will form, and since temperature is low, 4 degrees, so density will be maximum, so it will sink there. And because salinity will be more, temperature will be less, so because of higher density, that water will sink in the polar region, both in this Atlantic, North Atlantic and Arctic, both area, it will sink, and then in equatorial region, because you have higher heating, so it will become lighter and it will come. So to create the vacuum, this water slowly moves and comes into the this equatorial region, and there it will come and again go back to fill the gap in the polar region. So this is a continuous process, but in between it can keep on changing. Like sometime back, you know, Indian right now where Himalaya is there, once upon there is a Tethyan Sea. You know, everybody knows that. So the Tethyan Sea, our Indian Ocean was directly connected to the Atlantic. So there was a water movement directly from Indian Ocean or Tethyan Ocean to the Pacific, and this side towards the Atlantic. But now, because Himalaya has come there, the Tethyan Ocean is the water movement is restricted. And because of that, you know, the last almost 20 million years, temperature of the globe has gone down by almost 8 degrees centigrade, because equatorial water is not able to move to the Antarctic region, and Antarctic ice sheet has grown. So this type of means change in direction keeps on taking place, and because of that, lot of interesting climatic change has taken place in the past.
Okay, thank you, sir. So thank you so much, sir. So we will go ahead now, and I will invite our director, Professor Anish Kumar Srivastav, sir, for concluding remarks. Sir, please, sir.
Thanks for giving me another opportunity. And the thing is, the kind of lectures we had, it's really mind blowing. I don't have any alternate words to use. Both the lectures were so excellent and inspiring for students, teachers, and people like us also. Anand started talking about optimum syllabus, but the thing is, who will decide? So he started throwing questions, and those were very relevant questions. Gyan ka bhav, ya bhav, I don't understand. But the thing is, these things are really important, that what is the optimum syllabus we should have. And then he talked about crystallography, crystal growth, then different models, video clippings. He also said the useful video clippings, how to identify from YouTube and all those things. And then he talked about materials stress, mental stress, solidification. So philosophy, science, and education. 3 things he tried to put together, but in a very clear way. That's really amazing, because everything directly went to mind. You don't have to think. No road was required in between Anand's talk and the participants' mind. Connectivity was not required. It was directly going to the mind. So then another lecture, Blue Economy, Scientific and Technological Interventions by our Sunil. It's another word actually for a normal common man, at least to me, who works on materials and to some extent crystallography and technology development related to materials. It's really a new thing what we learned today, like what is the control of the role of ocean. And we cannot talk about control of ocean because it's a nature gifted thing. But the role of ocean, CO2 monitoring, oxygen producer, climate, how the climate regulation takes place due to the ocean geography, air we breathe, how much the contribution from the ocean. Then he talked about economy, which can be enhanced. I mean, the numbers which he was telling, I mean, I don't know how many zeros are there. I mean, one has to put all zeros on the page. A4 sheet may not be sufficient. So that kind of economy, one can think when if we can utilize the strength of ocean. So, and that's really, it will give a great contribution towards this our Atmanirbhar Bharat if we can tap the economy using the kind of the things we have related with the ocean. And then he talked about origin of ocean biological pump, and then another aspect of green energy, which is directly, of course, related with economy. So all these aspects, when we club both the lectures, I think we have learned a lot, and both the speakers have put the things in such a simple way that you don't have to apply your brain too much. You can directly understand what they have talked during their presentation. And I'm sure that participants, students, and all those who have heard this lecture or who are going to hear in future, because these things are going on YouTube, they will learn a lot from both these speakers. So I thank both the speakers and all the participants, and I wish that rest of the today and tomorrow's lectures will be in a similar way very useful for all of us. Thank you very much.
Thank you, sir. Thank you for your remarks. And now I invite Senior Scientist and Coordinator of Jigyasa CSIR-AMPRI, Dr. Sadanand Mishra, for vote of thanks. Dr. Mishra, please.
Thank you, Dr. Archana. This is the time of the vote of thanks, but I have seen that here, participant to speaker. पार्टिसिपेंट भी गुरु हैं और स्पीकर्स भी गुरु हैं। एक गुरु है, दूसरा महागुरु है। अब किसको धन्यवाद कैसे दिया जाए? रियली देखता हूं किसी ने वास्तव में कहा है कि जो वृक्ष होता है जितने ही उसमें ज्यादा फल होते हैं उतना ही झुकता है। तो मैं देख रहा हूं यहाँ पे हमारे जो इमिनेंट स्पीकर हैं और टुडे चीफ गेस्ट हैं, इतना बढ़िया लेक्चर, और जो एसोसिएट सॉरी जो हमारे गेस्ट ऑफ ऑनर हैं प्रोफेसर आनंद जी, इतना बढ़िया स्पीच दिया। और रियली आज हम जो कुछ भी है ये गुरुओं के ही थ्रू है, इसलिए गुरु को सबसे पहले हम नमन करते हैं। जो हमारे वेदों में और शास्त्रों में जो बोला गया है कि गुरु ब्रह्मा गुरु विष्णु गुरुदेवो महेश्वरा गुरु साक्षात परब्रह्म तस्मै श्री गुरुवे नमः, वास्तव में यह गलत नहीं। कबीरदास जी ने और आगे बढ़ करके उन्होंने लिखा कि गुरु गोविंद दो उखड़े काके लागू पाए, बलिहारी गुरु आपने गोविंद दियो बताए। तो आज मैं देख रहा हूं हमारे बीच में भटनाकर रिवार्डी है, इमिनेंट प्रोफेसर्स हैं, IITians हैं, डायरेक्टर्स हैं, ये सब केवल देन है गुरु की, और बिना गुरु कुछ भी नहीं है। तो रियली वी आर ग्लैड टू हैव सच enormous participation on this occasion. The large connectivity of participants strengthens us and it shows the grand success of the program. It is my privilege to propose vote of thanks on the auspicious occasion. The aim was to cultivate the scientific temperament among the students and teachers. Dear participant, please mute your mic. Dear participant,
Mr. Pankaj, please.
I am was to cultivate the scientific temperament among the students and teachers, encourage them to provide a deep insight into the emerging technologies and their application in various fields. This can prove beneficial for the both students and teachers. We are connected here under CSIR Jigyasa program. Around 1.10 lakhs students and teachers benefited by CSIR Jigyasa program till date. जिज्ञासा, रियली यदि जिज्ञासा के बारे में हम कहें तो ये पोएम मुझे बहुत ही प्रभावित करती है। जिज्ञासा और जानने की, उन्हें करीब से पहचानने की, जो सबका सृजन करता है, जो ढूंढो तो सब में है पर है कहीं नहीं, चाह और बढ़ जाती है उन्हें पाने की। क्या है, कैसे है, कहाँ है, कौन है, जन्म से मृत्यु तक, धरा से नभ तक, ये प्रबल इच्छा जानने की जिज्ञासा, उसे पाने की। मनुष्य हो या अन्य प्राणी, सबकी अपनी अपनी है वाणी, उत्सुकता जगी, खोज किए अंततः उसके हो लिए। नदी की तरह रोडों को चिरते चले, नदी की तरह रोडों को चिरते चले, बादलों को फाड़ के उजाले बिखरे, पवित्र करे, नूतन गति प्रदान करे, जिज्ञासा एक ज्ञान की धारा बहे। रियली ये कविता जो है बहुत ही इंस्पायर्ड करती है, इससे हम लोग बहुत कुछ सीख सकते हैं। So first of all, I would like to express my gratitude towards our chief guest, Professor Sunil Kumar Singh, Director, CSIR-AMPRI Goa, and well-renowned geochemist for his presence and giving wonderful talk on blue economy, scientific and technological intervention. Professor Sunil Kumar Singh explained about importance of blue economy and its contribution on planet Earth and its biological effect as well as and solar radiation effect on ocean and its effect on food and other factors and its global scenario. Professor Sunil Kumar Singh discussed about the anthropogenic activity and ocean global warming and post-glacial sea level rise. Further, he discussed about the oxidation, origin of Earth, ocean, and atmosphere. Really, I hope that teachers benefited by and motivated by such speech. Thank you, sir. Dear participants, आपको बताना चाहूंगा जो CSIR-AMPRI गोवा है, वो सी शोर पे बसा हुआ है और आप सबने जाना होगा समुद्र मंथन से इतने सारे रत्न, इतने सारे चीजें निकली थी। तो अंडर द लीडरशिप ऑफ प्रोफेसर सुनील कुमार, हमारे जो साइंटिस्ट हैं, नॉलेज का मंथन कर रहे हैं और रियली इससे हमारे देश की इकोनॉमी को समृद्धि मिलेगी। Thank you, sir, for your presence and motivational and kind speech, sir. I would like to express my special thanks to our guest of honor, Professor Ananda Subramaniam, Professor Department of Material Science Engineering, IIT Kanpur, for wonderful and mesmerizing lecture on the topic and for enlightening us all. His topic is learning with model, experiments, and video. During the COVID pandemic, we are also using the IT and this technique, learning with models, experiment, and video, it is a current demand. सर ने इतनी अच्छी, इतनी सिंपल और हिंदी लैंग्वेज में और छोटे छोटे एक्सपेरिमेंट दिखा करके और बड़ी चीज पे ले गए। रियली Thank you, sir, for your knowledge. Really, I salute your knowledge और टीचिंग लर्निंग। इस तरह की टीचिंग लर्निंग ये वास्तव में सर ने एक एग्जाम्पल दिया था। जब सर ने मुझसे डिस्कस किया कि मुझे क्या देना है, क्या बताना है, हमने कहा सर आप भी टीचर हैं, लेकिन ये बड़े लेवल में स्टूडेंट्स जो है स्कूल से आते हैं और आईआईटी में आते हैं, उनका मेन मोटिव होता है कि आईआईटी में हम कैसे रीच करें। तो आपको यही चीज बताना है कि जो लर्निंग प्रोसेस है, तो सर ने इतनी अच्छी लर्निंग प्रोसेस दिया, इसके लिए मैं सर को बहुत बहुत नमन करता हूँ। I would like to acknowledge my gratitude to Mr. Somit Srivastava, Deputy Commissioner KVS-RO Bhopal, Mr. P.S. Sardar, Deputy Commissioner KVS-RO for their coordination and NVS-RO for their coordination and support. Sir, यदि आप टीचर्स की लिस्ट टाइमली प्रोवाइड न करते तो ये वर्कशॉप हमारे लिए संभव नहीं, लेकिन इसमें मैं देख रहा हूँ अभी भी ये सेशन एंडिंग की ओर है। 354 पार्टिसिपेंट्स हैं, लेकिन हमारे पास जो रजिस्ट्रेशन है अब तक हो चुका है 600 टीचर्स का। ये बहुत बड़ी हमारे लिए उपलब्धि है। I would like to acknowledge my gratitude to Mr. Vinod Kumar, Deputy Commissioner, केंद्रीय विद्यालय संगठन रायपुर रीजन, Mr. Tajuddin Sheikh, Deputy Commissioner, केंद्रीय विद्यालय संगठन जबलपुर रीजन for their coordination and support. I would like to acknowledge my gratitude to Director and Principal of Private School for nomination of faculty. यहाँ पे बता दें अराउंड 30 टीचर्स प्राइवेट स्कूल से हमारे पास जुड़े हुए हैं, जो भोपाल की वेल रिनाउंड स्कूल है, जैसे सागर पब्लिक स्कूल, एनआरआई स्कूल, डीपीएस स्कूल, कार्मल कॉन्वेंट स्कूल, यहाँ से 30 टीचर्स हमारे इसमें जुड़े हुए हैं। तो I would like to acknowledge my gratitude to District Education Officer Bhopal for his coordination and support and nominating faculties in very short time. Actually कल मैं डिस्ट्रिक्ट एजुकेशन ऑफिसर से मिला और उन्होंने इमीडिएट 30 टीचर्स की लिस्ट मुझे पकड़ा दिया और बोला फोन करके कि आप सबको ज्वाइन करना है, और आज वो सारे टीचर्स हमारे इसमें रजिस्टर्ड है। इसलिए मैं डिस्ट्रिक्ट एजुकेशन ऑफिसर जो भोपाल है उनको तहे दिल से धन्यवाद देना चाहता हूँ कि उन्हीं जिसकी वजह से ये हमारे पार्टिसिपेंट आए और ये प्रोग्राम सक्सेस हो रहा है। I would like to express my gratitude towards our mentor Dr. Avnish Kumar Srivastava, Director CSIR-AMPRI Bhopal, for awarding me a chance to organize the 5th National Science Teacher Workshop 2022 on Self-Reliant India using cutting edge science. Sir, really आपका जो मोटिवेशन है, आपका जो इंस्पिरेशन है, हम लोग इतनी बड़ी हाइट को अचीव कर रहे हैं, इसके लिए आपको सर बहुत बहुत धन्यवाद, और आशा करता हूं कि गाइडेंस की सपोर्ट हमेशा मिलता रहेगा और हम लोग अच्छे कार्य करते रहें, नॉलेज की डिस्ट्रीब्यूशन करते हैं। I would like to thank Dr. Archana Singh, Principal Scientist CSIR-AMPRI for her cooperation and support. A big thanks you to teachers who were the main pillar and made this program a success. I heartily convey my gratitude to all scientists, technical officers, admin officers, research fellows, ACSIR research scholars, and all the staff of CSIR-AMPRI Bhopal for making the program a success. Last but not least, I would like to thank our IT team, Engineer Naren Singh, Scientist, Engineer R.S. Ahirwar, Chief Scientist, and Dr. A.K. Singh, Chief Scientist, for their continuous support and excellent coordination. Thank you, sir. यदि मैं अपने जो साथी हैं, जो हमारे साथ लगातार रह रहे हैं, काम कर रहे हैं, जिसमें से जो टीम है, मिस शिवानी पांडे, तन्मय सरदार एंड मिस दिव्या, यदि इनको हम धन्यवाद ना दें तो वास्तव में बहुत बड़ी हमारे लिए कमी, क्योंकि विदाउट इनके सपोर्ट से मैं इतना बड़े अचीवमेंट नहीं प्राप्त कर सकता। थैंक यू वंस अगेन टू ऑल। जय हिंद, जय भारत। डियर पार्टिसिपेंट, नेक्स्ट सेशन हमारा शुरू होगा आफ्टर 5 मिनट, और जो आज के इमिनेंट स्पीकर्स हैं प्रोफेसर अनुज हुंडे,